In order to see things in 3D, each eye must see a slightly different picture. The brain puts the two pictures together to form one 3D image. Today, we often need to wear special glasses to be able to see 3D photographs or movies. The photo or the movie screen actually displays two images, and the glasses ensure that each eye only perceives the image that it is intended to see. Today, we use either passive glasses or active glasses. Passive glasses are cheap and don't contain any active components. Active glasses, on the other hand, typically contain an electronic device to alternatingly block the view of the left eye and the right eye. This is achieved by using similar technology to the one used in LCD panels. The first way to send different images into the left and right eyes of spectators in a cinema or auditorium is to put a so-called Z-screen in front of a projector that successively projects images for the left and the right eye. The Z-screen changes the polarization of the light from vertical to horizontal every 1/120th of a second, making sure that the polarization for the left eye is perpendicular to the one for the right eye. The light is reflected by a screen that's coded to retain the polarization. Because the spectators are wearing passive 3D glasses with perpendicularly polarized lenses, they can see 3D images. For this system to work, the images need to be projected at double speed, because each eye needs to be fed enough images to get the impression of a smooth motion. This can only be achieved with CRT and DLP projectors. LCD projectors are too slow. With dual projection, it's possible to omit the expensive Z-screen. The images from each projector are destined for either the left or the right eye. In front of each projector lens, there's a linear polarizer, and as in the previous setup, the polarization for the left eye is perpendicular to the one for the right eye. The images are simultaneously projected on the screen so they overlap, resulting in a blurry image. But since the spectators are also wearing passive 3D glasses with perpendicularly polarized lenses, they see clear and well-defined 3D images. Since this setup uses two projectors, the images can be projected at normal speed. The previous systems were based on the polarization of light. However, 3D projection can equally be based on the color of light. The Infiltech 3D viewing system requires a dual projection setup but no special screen or wall to achieve a stereoscopic effect. This is an important consideration for cinema owners since special polarization-retaining projection screens tend to deteriorate the quality of ordinary 2D projections. Each projector in the Infitech setup uses a different part of the color spectrum. This calls for some explanation. The visible color spectrum can be divided into red, green, and blue color tones. In the Infitech system, these color tones are split. Images for the left eye are recorded in a different part of the color spectrum than images for the right eye. Both these images are projected simultaneously on a screen. Colored 3D glasses are used to filter out the exact image for each eye. The advantages of the Infitech system are that the images are clear, bright, and absolutely flicker-free. The Infitech glasses are passive 3D glasses, so they're cheaper than active glasses and only slightly more expensive than polarizer glasses. With active 3D, the images are projected at double speed. A synchronizing device is installed in the auditorium to control the spectator's active glasses by means of infrared beams. Each time an image destined for the left eye is projected, the glasses completely block the lens in front of the right eye and vice versa.